Hello, and thanks for reviewing the following presentation given during the 2020 Data Science Symposium webinar series. The Data Science Symposium is one of several services provided by the University of Cincinnati's Center for Business Analytics, a part of the Lindner College of Business. Through leadership forums, student projects, public education events, including the Data Science Symposium and the Analytics Summit this spring, as well as professional development courses, the Center provides businesses and organizations with game-changing capabilities to drive analytics for competitive advantage, regardless of size or type of organization you represent. For more information about the Center, including how to join our 25 member organizations and the benefits they enjoy, please contact either myself or Dr. Michael Fry here at UC. Now, enjoy the following presentation.
Hello, and welcome to our talk today entitled Sentiment Analysis 2.0. I'd like to start by thanking the Center for Business Analytics for inviting us to present our research today with you. We'd like to thank Mike and Glenn in particular. I am Dr. James Lee, Director of the Digital Scholarship Center, among other titles that you can see on the screen and with which I won't bore you. I'm joined today by Dr. Lindsay Nichols, who will be presenting some of our center's innovative work in text mining and sentiment analysis. And she's really our linguistics guru, and she's an expert in corpus linguistics. So I'm excited to share her expertise with all of you. The work we'll be presenting today has been conducted through the Digital Scholarship Center, which is a university-wide research center supported by the Office of the Provost, the UC Libraries, and the College of Arts and Sciences. The DSC is one of 6 digital research centers worldwide funded by the Andrew W. Mellon Foundation under their designation of digital integrators, which in their definition are research centers whose stated mission is to break down walls between silos and to cross wires across our institution. In practice, this has led to research projects in collaboration with 9 colleges at UC, and we are one of the anchor teams in the Digital Futures Initiative for Transdisciplinary Research led by the Office of the Vice President of Research. Our methods involve combining machine learning techniques using a blend of supervised and unsupervised techniques tailored for our specific research questions across a wide range of disciplines. We work primarily on the mountain of unstructured data that has tremendous potential, which we think is largely untapped for research, such as qualitative data sets containing text, images, and sound. We produce human interpretable interactive data visualizations. So our subject matter expert collaborators can really explore the results of our models and the underlying data sets so they can draw meaning and connect the dots between trends in the data that we produce. So here, as an example, is a vector space model and an information retrieval system that is backed by deep learning methods, but which have translated into an interactive analytics platform tailored for unstructured text discovery and trend analysis in biomedical research. Backing this is a deep learning architecture, but we don't forward that. What we forward is the document retrieval and the trends in the linguistic structure. In the course of our projects combining natural language processing and text mining methods, several of our collaborators in passing have mentioned that what we're performing is in effect a type of next generation sentiment analysis. And that's the direction we're pushing in today and that we're presenting to you. Lindsay will show this idea in some detail in the following slides, but by way of introduction, I want to frame the concept of sentiment analysis 2.0 as a methodology to apply linguistic reasoning to machine learning methods to understand semantic and emotional context and content in text data sets with far more nuance than binary categories like good, bad, positive, negative, or like and dislike. And as a result, we think the approach to text data sets is far more accurate, so we can extract meaning from it. Can we understand human sentiment in its full complexity? That's a question we ask ourselves a lot. And we believe with machine learning, we think the answer is yes, because we have the capability to identify and represent language trends in n dimensions, determined by what is actually happening in the data itself, and not by our preset assumptions of what the limited range of human responses and reactions can look like that we can impose on the text. But we can only do this if we have a sound understanding of how language behaves. And linguistics provides a solid basis for this understanding the mechanics of language. In general, and this is our outreach to you, we are looking for partners with business problems and applied use cases where we can apply our NLP methods combined with linguistics techniques. So please do get in contact with us if you're interested in engaging more with us or have further questions. Mike and Glenn can put you in contact with us. So without further ado, I want to introduce Dr. Lindsay Nichols now, who will present how we have used a combination of corpus linguistics and machine learning to begin to move us toward this idea of sentiment analysis 2.0. Thank you, Lindsay.
Hello, everyone. Thank you for joining us today. And thank you to Dr. Lee for inviting me to present with him today on this topic. I'll start out just by simply talking about sentiment analysis as it stands. As many of you already know, sentiment analysis is used to identify and extract user opinions about specific entities. We want to know what the sentiment is that's being expressed about this item, whether that be a product or a service, or perhaps an organization, or more abstractly, it could be an idea or an issue. As Dr. Lee mentioned, this has been grounded in machine learning techniques and having the use of manual training data, and has been they've been implementing deep learning into this, which has been praised for its ability to perform independent of expert knowledge and linguistic resources. And what I'm going to try to propose is that we might want to think about combining the two of those to then enhance the capabilities of sentiment analysis. And we'll get to that as we get further in the presentation. Sentiment analysis performs 3 subtasks: opinion target extraction, which just means it's a way of extracting or finding that target that we are offering a sentiment or opinion about, or that the expression, the text, is offering that sentiment or opinion about. Aspect category detection is what categories that target actually belongs to, what entity does it belong to, and what attribute are we expressing our sentiment about. So the attribute meaning maybe quality, for example, if we want something's good or bad. So that brings us to that last part, which is sentiment polarity. And that's the part that I'm really going to focus most on today. And that's this idea of a positive negative binary and how we are assigning these qualities to the entities that we're expressing this sentiment about. You also might see a 4-way sentiment polarity. I mean, we see the positive negative, but you might also see neutral or conflict added in there as well. But for now, I'll just kind of talk about it on this binary scale. When we think about it on the binary scale, we want to also start to consider what these terms actually mean. What is positive and what is negative? Often we think about certain words when we want to think, oh, this is positive. And so we have certain words that we use to express a positive sentiment. Here are some examples on the right-hand side. Traditionally, if we are reading these words, we might think, oh, this is a positive assessment or an evaluation about this entity or this thing that I'm talking about. Conversely, on the left-hand side, these are negative assessments or negative evaluations that we're expressing about a specific entity. However, that can be problematic because positive and negative are generally very arbitrary sentiment labels. What exactly is positive and what is negative? Now, on the previous slide, I showed you that we can assign some words to those sort of poles, correct? But if we think about in English specifically, we have over 3,000 different words that express different sentiments and different human emotions. And we're trying to narrow them down into classifying into these 2 ways, either positive or negative. So this oversimplification has the potential to prevent our ability to capture the true breadth of human sentiment. So without any affective grounding, meaning it's not telling me any specific emotion that's being addressed, there's a sort of lack of effectiveness in our ability to really define that sentiment. Also, another complication is the diverging use across domains. So taking 2 examples from the previous slide, challenging, which traditionally we might associate with a negative feeling, and interesting with a positive. But if we swap those into a different domain, they might mean the exact opposite of what we would traditionally assume. I'm going to assess an art piece, like maybe a painting or something that I'm looking at, as very interesting. That's a positive assessment. But if I go to a restaurant and I eat something and I say that the food is interesting, I'm not sure that the chef will take as kindly to that compliment. Then there's the complication of linguistic ambiguity and problematic forms, some of which are listed here, and there are more. The ones on the right-hand side are very specifically tied to user-generated data that we might see through Twitter or Reddit posts. And I think that metaphor and invoked affect are two of the most common that we're going to see, because English, if we're talking about English in this case, is a very indirect language. And so we use a lot of metaphor, and we use a lot of affect that's expressed implicitly and not with any overt terms or any specific terms that are going to very easily attach themselves to either a positive or negative sentiment. So what we're proposing is to actually incorporate some linguistic theory back into this process and into this model. It's been performing quite well using the machine learning techniques and using deep learning. But what I think we can do is make it much more sophisticated and increase it into n dimensions, as Dr. Lee had mentioned. Rather than this unidimensional positive negative, we can add some more specificity to that analysis to give us a little bit more insight about what the sentiment is about whatever text it is that we're analyzing. So the linguistic theory that I'm specifically proposing for this portion is appraisal. And appraisal theory is very well suited to sentiment analysis because it's concerned with emotional reactions, judgments of behavior, and evaluation of aesthetics or phenomena. And these can be just general emotions that we're experiencing as humans. You know, if I'm feeling happiness or sadness, etc. It may not be about a specific entity, but just the emotion that I'm experiencing. Then the judgments of behavior, that can be a judgment about a person or an organization. And then the evaluation of aesthetics might be actual things, products, services, places of business, etc. Maybe that you would see like a consumer review. And we would define those as expressions of appreciation. I'm commenting on that product or service's composition and its valuation, etc. And within appraisal, there are 12 dimensions, and each of those 12 dimensions sit on their own polarity scale. So they have a positive and negative end, leaving us with about 24 different labels that we can actually go through and use. How we're applying this is through a partnership that we have with Cincy Tech, where they're wanting to analyze user-generated data through Twitter that is related to human sentiment regarding the COVID-19 pandemic. As I mentioned before, some of the complications of current sentiment analysis approach is that this user-generated data is very problematic in that it uses a lot of metaphor, and it uses a lot of misspelling and grammatical error and a lot of implicit emotions or a lot of invoked affect. So what we're doing is, to start out, we're going to use human classification to train the model. So having 10,000 different tweets, and then classifying those into those 24 different categories on the 12 dimensions of appraisal to give us some more specificity in terms of what sentiment it is that we're seeing happen out there in the world of Twitter when talking about COVID-19. And then we're going to use that data to train the system and to establish rules and run a classifier that can then hopefully perform by being able to perform on its own to do these different classifications beyond our unidimensional positive and negative. Now, I have to apologize a little bit because we're sort of in a theoretical phase of this, meaning that we haven't practiced it yet. I haven't seen the results of using this sentiment analysis, using the classifier after this training data has been input. But right now, we are just in the beginning stages of this. So we're doing that classification at the moment. Here's just an example of a timeline of tweets about COVID-19. I know it looks kind of like a paint splatter, but each individual dot that you're seeing or node is representative of one tweet. If the node is larger, it just means that it's more popular, it had more retweets. So I just chose 3 at random. If we look at the one on the left, in the future, people will look back at this time and think how archaic our medical methods and decisions on how to handle this epidemic were. But no one person really knows the best approach. The hindsight will be brutal. Now, if I think about sentiment analysis as it stands, I can assign a positive or label to this, not positive or negative label to this. And probably based on some of the words in there, maybe archaic, brutal, might give me that indication that it's negative, right? But other than that, there's not a lot of specific terms that are giving us this strong negative emotion, right? A lot of it is implicit, or a lot of it's expressed through invoked affect. If we're able to apply appraisal theory, and it can classify based on those 12 dimensions that we've trained the data to learn how to do, we might come up with something a little bit different, something a little bit more nuanced. And in this case, I have labeled it as insecurity and incapacity. Now, we're still seeing that it's negative overall, right? Insecurity and incapacity are representative of negative emotions, but it gives us a little bit more detail about what exactly that emotion is and what's being expressed. Just knowing through Twitter data that 80% of the tweets out there are negative in nature doesn't really give us a lot of information about that. But if we're able to say 50% of them are expressing sentiment of insecurity, then that is, we get a little bit better handle on what's really going on with the users on Twitter, specifically related to this text, or this data set rather. And that, I think, is easier to grasp onto and easier to use and to benefit from when you're performing a research study or trying to really learn about the human sentiment. And then, so insecurity and incapacity are two examples, and the other two that I won't go through just for sake of time have expressions of different emotions that come out of the appraisal theory. What we can do next, then, that's the way we can enhance what already exists, right? So we have the positive, negative poles of sentiment analysis, sentiment as we know it, expressing human emotions and attitudes, or about specific behaviors or about entities. But there's another way that we can expand this theory as well. It moves beyond what we might normally think of as human emotion, but it still is an expression of attitude in some way. And that is if we look at the linguistic theory of modality and modalization. So we also express modalization through language, and it can be captured in a similar process to what we do with sentiment analysis. If we're able to impart some kind of linguistic theory in that initial training, in the initial human classification of that, to then help the model itself and the machine be able to provide a better, more enhanced output. Modality expresses attitudes or judgments as to the likelihood of probability rather of something happening or being. So this adds some intermediary positions to that binary scale. And this binary scale isn't positive negative, but instead it's certain or uncertain. Or we have it definitely will happen or it definitely will not happen. And then we have these intermediary positions that we know we kind of live in oftentimes, right? We think it's possible that it could happen. We don't know for sure, but we express that through a range of different language options somewhere in the middle. And that gives us some idea about where the probability of this happening or being lies. So we're also trying to implement this as an aspect of sentiment analysis through a project that we're working on with Cincinnati Children's Hospital in their hospital medicine division. And they're wanting to be able to reliably identify language that's indicative of diagnostic uncertainty in physician notes, and then use that knowledge to create a predictive model that they can implement in their charting system. So in live charting, they'll be able to filter into certain and uncertain diagnosis patients. So to do this, we have to start by obviously organizing some data so that we can do some of this initial classification by ourselves and this initial analysis. So they have some case data from notes of patients where the doctor physically flagged those patients as uncertain diagnosis. So that's kind of our gold standard. We know that these patients have an uncertain diagnosis. And then we have the matched control set, which there's 4 times the amount of notes, but those patients were not flagged. They went through the same division, had the same physicians working on them, etc. Then we want to perform a qualitative analysis. We've already done this, sorry. We went to perform a qualitative analysis on that case data to get a better grasp and understanding about what diagnostic uncertainty looks like in language. We already kind of know what uncertainty looks like in language. That's been well established through linguistic studies over the past several decades. And we know that there are certain words that people use to indicate a level of uncertainty. However, we don't know what kind of nuanced language is used in this specific register in physicians' language. How do they denote some kind of linguistic uncertainty or diagnostic uncertainty rather? Do they use some of those traditional linguistic terms that represent uncertainty? Potentially, but they also will likely include others, and they will also not use some of them. So we performed a qualitative analysis to determine what those are. The goal of that being to understand that and be able to tag the corpus to help train the machine learning algorithm and the classifier so that when we feed new data into this system or into this model, that it will give us an output that will automatically be able to filter things into patients that have an uncertain diagnosis and a certain diagnosis based on the language that's found in that note. This is just a brief example of kind of what I did to go through that qualitative analysis process. I won't go into too much detail here, but this is just a collocational network. A collocate is a word that is two words that are co-occurring with one another. So if I have the search term of diagnosis, all of those words that are surrounding it are its collocates, words that are commonly co-occurring with diagnosis. And of course, the closer the node is, the higher the collocation strength. And then what I can do with this is double click on one of those collocates and it will provide me with a network, and what you see with uncertain on the left-hand side. Then uncertain will then have its own collocates listed, and the ones that they share are highlighted in orange. And this is just one of the steps of the process of me being able to go through and figure out what words are actually indicative or what phrases are indicative of diagnostic uncertainty, so that we can take an inventory of that, get a good list of those, compare them to the match control set, and then once we have confirmed what indicators exist, be able to test this through running it through an algorithm and through a classifier. So that's kind of the stage we're getting to right now. In closing, I think that this has the potential to produce a really enhanced way of identifying human sentiment in text. We've been able to do the positive, negative, but like I said, I think from a linguistic standpoint, those labels and those classifications are quite arbitrary, and they don't really capture the breadth or the depth of human sentiment. There's a lot of other ways that we can express that. And if we impart some linguistic theory in that, the hope is that we can provide a more nuanced results, more nuanced classification of what that human sentiment is, and give us a better understanding and grasp of that in our research. This has far-reaching applications across domains. I only mentioned two that we're talking about or that we're working in, but this could apply to other domains as well. And there's a lot of opportunity for further growth. We're very much in the infancy of this. We're still trying to test this. It will need lots of refinement. And in the future, as we apply it to different domains, as we perhaps apply more linguistic theory to it, as we maybe expand the dimensions even further, I think that there's a lot of potential for this to continue to grow as a future model that produces much more enhanced sentiment analysis. Thank you. If you have any questions, we will be around.